The last section in this unit is solving rational equations, so we're trying to figure out what x is equal to. If you have something like this, x over 3 equals 4 over 3, the only way that x over 3 can be equal to 4 over 3 is if x is equal to 4. So when your denominators are already the same, you can just remove those and set the numerators equal to each other. Here I have a situation where our denominators are not the same. So yes, you could cross multiply. You're used to, when you have a proportion, just cross multiplying. So 2 times x is 2x, 4 times 1 is 4, and we get that x equals 2. Instead, I want to kind of show you a different strategy for doing this, and that way when we get on to more complicated problems that you won't be allowed to cross multiply, this strategy will work as well. So yes, you can cross multiply if you only have one ratio or one fraction equal to another. Instead, I'm going to look at this being 4. That's the same as 2 times 2. So I'm going to write that 2 times 2. This one only has one 2. It's still missing a 2. Since this one already has the common denominator, I'm going to leave the numerator alone. This one does not have the common denominator. It needs a second 2. So I'm going to take the 1 and multiply that times 2. So x equals 2. This may have been more confusing because the example is so easy and you're used to cross multiplying. So hopefully as we get to more complicated examples, it'll make a little bit more sense. So here, my denominator is 3x, here it's 4. My common denominator would be 3x and 4. This one already has a 3x, but it's missing the 4. So I'm going to take what's on top, x minus 2, and I'm going to multiply it by what it's missing, which is a 4. On this side, the 1 is still missing the 3x, so I need to multiply that times 3x. This was basically cross multiplying because 3x times 1 is what I have right here, 4 times x minus 2 is what I have right here. I would distribute the 4, so I have 4x minus 8 equals 3x. Add 8 to both sides, and then subtract 3x, so x equals 8. I also need to look at what my domain restrictions are. X is not allowed to be 0. Since it's 8, that's fine. So my final answer would be x equals 8. So here's another one where you could cross multiply. Instead, recognize that the denominators are already the same. The only way that these two things could be equal to each other then is if the numerators were equal to each other. So 5x would have to be equal to 3x plus 4. If I subtract 3x, I get 2x equals 4. Divide both sides by 2, and I get that x equals 2. When I look at my domain restrictions, x is not allowed to be equal to 2. That means that I cannot use this. This answer is called an extraneous solution. If that comes up where you've crossed out every single possible x that you have because it's a domain restriction, then you're just simply going to write no solution. So there is no value for x that would be true in this equation. Here's where you've got one where you can't cross multiply. So we would look at factoring the denominators first. So x squared minus 16, that's a perfect square minus a perfect square. That would factor into x plus 4 times x minus 4. This one is already factored. This one is the exact same thing, so it would be x plus 4 and x minus 4. When we look at what the common denominator would be, it would have both an x plus 4 and an x minus 4. This first one already has both for the common denominator, so I'm just going to leave the 4 exactly the way it is. Then I have a plus, then a 5. The 5 is above an x plus 4, but it's still missing an x minus 4, so I'm going to put in the x minus 4. And that's going to be equal to, this x plus 4 already has the common denominator, so I don't need to add anything to that. That's just going to be x plus 4. So now I need to distribute the 5. So I have 4 plus 5x minus 20 equals x plus 4. So if I were to combine all of my like terms, I'm going to move all of my x's to the left and all of my constants to the right. I get 4x equals 20. Divide both sides by 4. I get that x equals 5. I check for my extraneous solutions. I know that in my domain restrictions, x is not allowed to be 4 or negative 4. Since x equals 5, that's okay, so my final answer is x equals 5. We'll go ahead and do one more example. When you have a case like this, where I don't have a fraction, remember any number can be written as a fraction. This is simply over 1. My common denominator would have both a 1 and an x in it. Well, when you multiply something by 1, it doesn't change the value, so really it's just a common denominator of x. This first one already has that, so I'm going to leave the 3x minus 6 exactly as it is, plus this one is over 1, so I need it to be over x, so it's missing the x, so 1 times x is x. The 10 is already over x, so I'm leaving that alone. The 4 is already over x, so I'm leaving that one alone. I'm going to combine my like terms, so 3x plus x is 4x. I'll add that 6 to the other side, so that would be 20. Divide both sides by 4, I get that x equals 5. For my domain restrictions, x is not allowed to equal 0, so I don't have any extraneous solutions, so that means that 5 is my final answer. So hopefully that was enough that you can go ahead and start working on the problems to the right.